Mrs. Krim, what's going on with your lobster?
Oh, well, what do you call a lobster that won't wear a face mask?
I don't know, what?
Shellfish. Because, he's got a shell. He's a shellfish, Okay, whatever.
So good. You know you love it deep inside.
Yeah, you keep coming back for more.
You know you're having a whale of a time with all these puns.
We are. But guess what? You've now made it for lesson
5.
Session 3. Video 3.
And we're on page 91 because we skipped 89 and 90.
Yes,
so
we
have
did.
your books ready to go.
All right. And so they gave us this donut and made us want to go get donuts.
So hungry.
It's been a long time since lunch. But then they told us that this donut shop sells donuts in boxes that each contain 13 dozens donuts.
Baker's
That's
dozen.
a baker's dozen,
When
I
you
know.
get one extra after a dozen, which is 12, which is
I
a real thing. If you buy a dozen donuts, you usually get one more.
You do. If 728 donuts were sold in one day, how many boxes of donuts were sold? Seems like a reasonable thing. So, what did they do here?
Well, it looks like they were trying to use a multiples chart to estimate a reasonable start point for our number of boxes and donuts.
Oh, I like that.
So, if they are 13 donuts in a box and we start with 10, well, that gets us to 130. That's not anywhere close to 728.
No, we got a ways to go.
Yep. 20 boxes would be 260. Nope. 30 boxes, 390. Nope. 40 boxes, 520. Keep going.
Getting closer.
Getting closer. 50 boxes, 650. Closer. 60 boxes, 780. Too high.
So
So-
we back down to the 50, right?
So
Yeah.
somewhere in between here
is our quotient.
be our actual quotient.
Ooh,
So
there we go. So we know it's more than 50, less than 60.
yeah, which means 50's a real good starting point for us.
It is. So then we went ahead and made an area model. Okay. So what goes in there? It's our
Dividend.
And over here goes our
Divisor.
Awesome. And so then eventually we'll get our quotient up at the top. So we started here with our 728, and we decided we wanted to take 50 of those out, right? 50 sets.
So we put our 50 up here as our partial quotient. We multiply 50 and 13, which is 650, and then we subtract that so that we know what we have left over because we've already used 50 sets. So when I subtract, I get 78. I bring that 78 over to our next box.
We still got to break it down.
Yep. So I do 78 and I go, 13. I bet I could double that, get 26 and then double that. I could do that 6 times.
Yeah, I bet you could.
And 6 times 13, well, wouldn't you know, that equals 78. So I subtract, I get 0, no remainders. I have my partial quotient of 6 up here, and now I just have to add my 50 plus my 6 to get 56, which is our quotient.
There we go. And we said it was going to be between 50 and 60, and lo and behold,
It is.
so funny how that works. All right. And so now we have a couple of questions regarding that lovely model. So the first question said, what was 13 multiplied by first? So what did we first multiply our 13 by?
There it is, 50.
50. Okay? So we multiplied it by 50 and we took out that 650 of those. So then next,
What equation in the area model shows this, meaning 13 was multiplied by what? Well, it's this 13 times 50 equals 650.
absolutely.
That's kind of a multiple.
Yeah, it works. All right, and then why do you subtract 650 from 728? Well, that's the number of sets that we just took out, right? So it tells us how many more we need to still break down, how many more sets we have to work with. So when we take out that 50 sets of 650, okay, that just leaves us with, a few more sets to find.
I don't know. Take out what we've already
Used. I don't know.
used. I didn't go about that great.
That's all right. You get the idea. but took him out.
Take it out. We already used it. It's already been factored in.
That's right. Or factored out. Or
Factored
whichever
out.
way. It's one or the other. All right, so then the last question said, what is the second partial quotient?
Well, here's our first partial quotient of 50. That means our second one is
6.
Meep.
Okay. So looking at that information, we can break that down and, determine some different things about it. So there we go.
All
We
right.
did page 91.
Next page already.
Woo!
I'm sitting here looking at all of our great props. I don't know why we didn't just get donut props.
I know, we
It's
should
really
have.
hurting my soul a little bit.
No, I really want that donut right now.
Donut. All right. This has no donuts. I feel better about my life.
Well, I know. I still want one though.
No.
All right, so this one says we have a table. I can see that is. Mm-hmm. And we're estimating 851 divided by 37. So how many of those sets of 37 can I get out of 851?
Well, we're just multiplying by 10, so I'll take the 37, multiply by 10, 370, not close. 20 would be 740. 30 would be 1,110. Getting
A little over
a
the
little
top.
over. And they did 40 just for good measure, I guess, for 1,480, real over the top.
Had to fill out the table, I guess, right?
Yeah, but 740, well, that's smaller than 850.
Right.
1,110, bigger than 850, so
We know it's going to be
Probably.
right there in between 20 and 30.
we just have to see which one of these says that. A number between 30 and 40. No.
Way too big.
Yep. About
It's a-
15.
It's a whale of a number.
Whale of a number. So big. Anyway, about 15. What? No.
Too small.
A number between 20 and 30.
We said that.
And you know what? It's always a good strategy just to double check that last one.
Because we know sometimes there's more than one answer, right?
Right. Or maybe you just misread it.
That's true. We've done that.
About 42. No.
No, too high.
That's over there. That's
Yep.
ridiculous. Ridiculous.
We did it.
All right, on to number 3. Complete the steps for using an area model to find the quotient 851 divided by 37. Oh, how nice. They started us on our path.
That was very nice.
We know about where to start.
We do.
Thank you, textbook.
I know.
Very
That's so weird. They
good.
haven't done many nice things like that.
No, they haven't.
Well, it looks kind of like the first thing they want us to do is kind of show that relationship between division here. Whoopsie, I just wrote on it. And multiplication. Okay? So if I have 851 divided by 37, that's the same thing as 37
times we don't
know yet.
But we know it's gonna have to equal 851.
Okay?
It's just the inverse.
That's it.
Inverse.
There we go. So it's that opposite function. Remember how we talked about that before? Well, maybe you don't, but we did. Just
We
in
did.
case.
We promise.
All right, and so then they wrote it here as an area model. 851 are, I put it all over the place, our dividend, right? Also, look, the product of that fact family. That's why we can reverse that. It's so cool. Okay, our question mark up here because we don't know what that is yet. And then what's over here? It's our divisor.
All right, so we already know where to start. We know the answer's somewhere in between 20 and 30, so let's just start with 20.
I think that makes sense.
And then I already know that 37 times 20 equals 740.
We already did that part.
But they want me to write it really small right here.
I know, so tiny.
So tiny. And then all I have to do is take my 740, oh my gosh, and subtract it from 851.
Ooh, we get a palindrome because it's 1, 1, 1. That was fun.
It was real fun. I liked it. So then I need to take my 111 and bring it up over to my next area model. And we need to figure out 37 times what gets us close. Well, they've kind of given
They
us a
did it
hint.
for us. I know. How nice
So
of them.
37 times 3 equals, and we don't know, but I'm going to hazard a guess. It's
111.
woo.
Woo.
And that
Rocket
means my
science here. Woo.
Woo! And that means my other partial quotient is 3.
It is
And
3.
I subtract, and I know that's going to be 0.
There you go. And then all we have to do is
Add 20 plus 3 equals 23.
23.
I just said 23 and wrote 23. I'm going to point out. That's like
Wait, clap, clap, clap.
Yay! Oh,
clap, clap.
thank you, thank you, thank you. Oh, I should have the whale bath. Thank you. So, 851 divided by 37, we now know is
23. There we go. All right, so now we have one last question.
Number 4.
Okay, so which of the following equations cannot, it says cannot, be used to represent the area model? So that kind of lets me think that maybe there are some of more than one that can, right? Because we have to find the one that cannot. So our first one says that 42 times that question mark is going to equal 4,326.
Well, yeah, because this is how I used to do area models.
Right?
Was my
This?
product in the
Yeah.
middle. Oh, I touched it. And then my 2.
Factors there on the
Yeah.
side, right?
So A is an answer, but we want the not answer.
Uh-huh.
So A is not right because it is right. Oh,
I know, that's kind of like an oxymoron kind of thing, right?
sorry.
Or wrong, or I don't know what.
All right. This next one says 42. I'm assuming that's a plus sign.
I think
right?
it
it's
is,
really
yeah.
blurry. It is a plus sign.
It is a plus sign.
42 plus 4,326 is going to equal this number. That doesn't
I
make
don't
sense
think
at
so.
all. There's no.
Yeah. So let's see if there are any other ones. 'Cause
Yeah.
which of the following equations?
There's an
cannot?
S. All right, so let's see. 4,326 divided by meow equals 42. Well, that would make sense that this divided by this would equal that.
Right, because that's a fact family, isn't it?
It is. So
All right.
this is correct, which means it's not the answer.
That's right.
Last one, 4,326 divided by 42 equals meow. Well,
That's exactly what that is,
Yeah.
right? So
So-
there's our dividend, there's our divisor, just where they're supposed to be. So
just B. B
Yeah.
is the only weird one.
I know.
There
Because
we
we can't
go.
add those and get something good. I just don't know.
Mrs. Crumb.
We're
Very
done!
good. Yes,
Woo!
they're not done.
No, they're not done.
Because they need to go and they need to take their exit ticket, exit